projects. In this video, we are going to explain about the project title E-commerce Product Recommendation System using collaborative filtering. Before diving into the execution, let me give you an overview of the project. The project aims to create a smarter recommendation system for e-commerce platforms using collaborative filtering. This technique looks at how users interact with products to suggest items they might like. By doing this, we hope to make the shopping experience better and boost sales by giving users recommendations that match their taste and past behavior. We are moving away from basic recommendation methods like rule based or popularity based systems because they often miss the mark when it comes to predicting what users really want. These traditional methods can't pick up on the small differences in what each person likes, which can lead to less accurate suggestions. In our project, we have developed two distinct recommendation systems to cater to different aspects of user preferences and behavior. The first system relies on content based filtering, where we analyze the textual descriptions of products using TF-IDF, term frequency inverse document frequency vectorization. This technique helps us understand the importance of words in product descriptions across a collection of products. We then calculate the similarity between products using a sigmoid kernel similarity calculation method. This system allows us to provide recommendations for a given product by finding items with similar descriptions. On the other hand, our second system employs collaborative filtering, specifically K nearest neighbors KNN. Instead of focusing on product descriptions, this system looks at the interactions between users and products. We represent these interactions in a sparse matrix where each row corresponds to a user and each column corresponds to a product. By identifying nearest neighbors in this matrix, we can recommend products to users based on the preferences and behaviors of similar users. Both systems leverage similarities between users or items to generate personalized recommendations. However, while the content based system looks at textual descriptions to find similarities between products, the collaborative filtering system analyzes user item interactions to identify patterns in user behavior. This allows us to provide recommendations that are more aligned with the individual preferences of users, ultimately enhancing the shopping experiences on e-commerce platforms. Lots of people will benefit from this project. E-commerce platforms will see more engagement and sales because users will find it easier to discover products they like. Users themselves will get better recommendations tailored to their taste and interest. And businesses will benefit from happier customers who are more likely to come back because they are getting suggestions that make sense for them. To implement this project, we need software and hardware requirements. Hardware requirements of the project are operating system of Windows, processor of Wi-Fi and above, RAM of 8 GB and above, hard disk of 25 GB and above. Software requirements of the project are application is Anaconda, primary language is Python, front-end framework is Flask, backend framework is Jupyter Notebook, databases SQLite 3, front-end technologies used in the project are HTML, CSS, JavaScript, and Bootstrap 4. Now let us execute the project. To execute this project, first we need to open the code folder which contains the project source code files. So here, this is the dataset folder. In this project, we have utilized cart product dataset. Cart product dataset is a comprehensive collection of data related to e-commerce transactions encompassing various files containing information about products, orders, user interactions, and ratings. This dataset serves as a rich source of insights into consumer behavior, product preferences, and purchasing patterns within the e-commerce platform. Let us open the IL file. So this file contains information about different product aisles. Each aisle has a unique identifier, that is the aisle ID, and a corresponding aisle name. So here these are the aisle names with their unique identifier aisle ID. So here we are having in total 134 aisle names with their unique ID. Now let us close this file. Let us open the departments file. Similar to the aisles file, this contains information about product departments. Each department has a unique identifier, that is the department ID and a department name. So here these are the department names. So here we are having 21 department names along with their unique department ID. Now let us close this file. Let us open the order products train file. This file contains details about products ordered in training orders. It includes information such as order ID, product ID, add to cart order, and whether the product was reordered. So here we can see. Now let us close this file. Let us open the products file. This file contains information about the products available for purchase. It includes details such as product ID, product name, aisle ID, and department ID. So here we can see the different product names which are available to purchase. Let us close this file. And this is the ratings beauty file. Let us open this. This file contains ratings or reviews related to beauty products. It includes information such as user ID, product ID, rating, and timestamp. So here we can see the ratings for the different products, beauty products. Now let us close this. So these files collectively provide comprehensive data about the products, orders, and user interactions within the e-commerce platform, enabling the development of recommendation systems and other data-driven analysis. This is the static folder. This folder consists of files related to CSS, JavaScript, and Bootstrap. This is the templates folder. This folder contains all the HTML pages used in the project. It includes files like index.html, about.html, and more, which represent different pages of the website. This is app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. This is collaborative filtering.py file. In collaborative filtering.py, a nearest neighbors model is initialized and fitted with orders, products, data to generate personalized product recommendations based on user item interactions. And here this is the content based filtering.py file. In content based.py, TF-IDF factorization and sigmoid kernel similarity calculation are utilized to quantify textual descriptions of products and generate recommendations based on similarities between product descriptions. So these files will be loaded in app.py file. And these are Python source files. This is signup.db file. This file is the database file used to store user information. First, we need to copy the path of the code folder from the address bar of the file explorer. Here, I'm copying the path. Now open the Anaconda prompt. Use the cd command followed by a space, and paste the copied path and hit enter. This command is used to change the current directory to the code folder's path. Compile the app.py file using the command python space app.py. So here I'm typing python space app.py and hit enter. This command will execute the Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, the Flask framework will host the application locally at the default address localhost, which is this, and port, which is this. Now copy this local link provided by the Flask framework. I'm copying the link and paste this copied link into any web browser. I usually prefer Google Chrome and hit enter. The homepage of the project is displayed in the browser. This is the front end built using Flask framework. If we are a new user, we need to register first. So click on sign up link here. So here we need to enter all these details to register. But I have already registered, so click on login here. So here we need to enter the username and the password which we have registered, which are static, and then click on login. We have logged in successfully and we are redirected to the prediction page. So in this project, we have developed two distinct recommendation systems to cater to different aspects of user preferences and behaviors. The first one is content-based filtering and the second one is collaborative-based filtering. First, we will see the content-based filtering. So click on it. So here we can see the different products with their product description. So here, this is the product chocolate sandwich cookies, and here we have the description for the product, that is cookies, cakes, and snacks. So we can select any of the product. So here we can see that the cart is empty and we have no recommendations yet. So from this product list, I'm going to select one product. So the product which I want to select is peanut butter cereal. So here we can see the description for the peanut butter, that is it is a cereal and it is used for breakfast. So this is the product which I want to add to cart. So click on add to cart. As soon as I click on add to cart, that product will be added to the cart. So here we can see the cart, that is your cart, and here this is the product which I have added, and here we even have the option to remove it from the cart. So here, this is the peanut butter cereal and the description for this was cereal or breakfast. And here we can see based on the content, based on the description for this product, we have got the similar products which are recommended to us. So here we can see multigrain peanut butter cereal, which is which is a spread and pantry. So this is the description for this product. And here we have another product which is recommended based on the content of the product which we have selected, that is organic promise strawberry field cereal. And here we have another product, that is mallow oats cereal. So in content based filtering, we will get the recommendations based on the content, that is based on the description of the product which we have selected. Let us select one more product from the product list. So here the product which I want is pizza for one, Suprema frozen pizza. So here we can see it is a frozen pizza, frozen. This is the description for the product. Now click on add to cart. So here we can see that this product is added to the cart. And here we have the recommendation for the product which we have selected. So here these are the recommendations based on the content. Now let us see the recommendations based on collaborative filtering. So click on it. So here again, we have the product list and we have the option to add to cart. And we also have the description here. And here we can see that the cart is empty and there are no recommendations yet. So here I am selecting yellow American cheese. And here we can see the description, that is specialty cheeses dairy X. So this is the product which I want to add to cart. So click on add to cart. So here we can see that this product is added to the cart, and we even have the option to remove it from the cart. And here we can see the recommendations you may also like. So these are the recommendations based on the product which we have selected. So in collaborative filtering, the system analyzes user item interactions to identify patterns in user behavior. So the products which are recommended are based on the preferences and behaviors of similar users. So here we can see these recommendations, that is pear had cedar, pear and blueberry baby breakfast, penny agate with Spanish. So these are the recommendations based on the preferences, not the description. Let us select one more product from the product list. So here I want Colombian coffee, 100% Colombian coffee. Click on add to product. So here we can see that Colombian coffee is added to the product, added to the cart. And here we even have the option to remove it from the cart. And here these are the recommendations based on the preferences. So these are the recommendations based on the preferences and behaviors of similar users. So in collaborative filtering, we recommend product to users based on the preferences and behaviors of similar users rather than the description. In this way, by selecting the product from the products list, we can get the recommendations. Now click on sign out link here. In this project, we have developed and implemented effective recommendation system for e-commerce platform using collaborative and content-based filtering techniques to make the shopping experience better and boost sales by giving users recommendations that match their taste and past behavior.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.